The following tools may be needed to complete these common repair procedures. For a general steering gear, you will need a magnetic base from a dial indicator, a tandem alignment caliper, a toe-in gauge, and a torque wrench. The first procedure involves checking the sector shaft for proper adjustment, and then performing a lash adjustment. First, set the sector shaft on the center of travel, or high point. Then remove the drag link. Next, check for sector shaft lash or end play by grasping the pitman arm and gently trying to rotate it. Looseness at this point indicates a sector shaft that is out of adjustment. To achieve proper adjustment, first loosen the jam nut and then slowly turn the shaft adjusting screw clockwise until you feel no play at the sector shaft. Next, continue turning the screw clockwise an additional 1/8 to 3/16 of a turn. While holding the adjusting screw in place, tighten the jam nut to the specifications found on ISIS. Finally, check for play by turning the steering wheel left to right, a quarter turn off center. You shouldn't feel any end play. For more information, go to Power Steering Gear TRW Ross TAS 40, 55, 65, and 85 on ISIS. If the driver complains that the truck is hard to steer in both directions, your task is to determine the fault and repair it. Refer to ISIS for the power steering diagnostics information as shown previously in this series, or on ISIS TSI 02-05-01. Some possible causes for a hard steering complaint are a faulty supply pump, improper axle and front end alignment, high operating temperature, foreign matter clogging piston relief, low oil level, air in the system, a front end load that is too heavy, or bent or damaged tie rods or kingpins. Plungers or poppet valves need to be adjusted if larger tires have been placed on the truck. There is reduced vehicle wheel cut, also known as turning angle. Originally, a pitman arm was mistimed, and then the condition was corrected. The steering gear is being installed on a different truck. The steering axle stop bolts have been bent or broken, or the steering axle U-bolts have been bent or broken. Refer to ISIS regarding vehicle poppet readjustment for RH Shepherd and TAS Power steering gears. Now we'll discuss steering angle alignment and how it affects steering and vehicle handling. Warning: always use safety stands with hydraulic jacks or hoists. Do not rely on jacks or hoists alone to carry the load. They can fail. First, let's define tandem alignment. If the front axle has heavy tire wear on the outside of one tire and the inside tread of the other, inspect the tandem rear axle suspension alignment. Tandem alignment can affect steering if the tandems are not parallel to the front axle. The truck may pull one direction or the other, depending which direction it's misaligned. The approved method of tandem alignment is through the use of a laser-type alignment device. But the following method will give you a ballpark reading that will help diagnose a steering complaint. Begin by driving the vehicle forward, then backward a few feet. Do this at least twice. Use light brake pressure if necessary. Next, roll forward slowly about 20 inches. Don't use the brakes to stop, because they may grab, jar the suspension, and prevent good measurements. Place a pair of jack stands about 6 feet in front of the truck in line with the steer wheels. Tie a string to the jack stand on the right side so that it's on the outside center line of the wheel on the same side. Next, run the string back and between the tandems, up to the front, and attach it to the other jack stand. Move the driver's side stand in until the string just touches the outside center line of the wheel on this side. Attach a magnetic base from a dial indicator to the center of the drive axle flange of the front tandem on the driver's side. Measure and record the distance between the center of the front axle hub and the center of the front tandem on the driver's side. Perform the same measurement on the passenger side and record the reading. If the two measurements are within 1/8 to 1/4 of an inch, the tandem is aligned with the front axle. Use a tandem alignment caliper to check rear tandem alignment to the front tandem by measuring from center to center of the rear tandems. Do this on both sides of the vehicle and compare the measurements. The tandem axles are in alignment if the measurements are within 1/8 of an inch. For more details about rear axle alignment, refer to TSI 93-14-01 on ISIS. The toe-in adjustment is the most important alignment factor to check when attempting to extend tire wear. Toe-in is the amount, in fractions of an inch, that the front wheels are closer together at the front than at the back, as viewed from the top of the truck. When the vehicle is driven, the forces acting on the front wheels tend to make the wheels toe out. To overcome this condition, the wheels are given a certain amount of toe-in. Incorrect toe-in will result in rapid tire wear. Excessive toe-in will produce a scuffing or a leather edge at the outside edge of both tire treads. For information about toe-in setting, refer to TSI 04-02-01 on ISIS. Caster is the amount in degrees the top of the kingpin leans toward the front or rear of the truck, as viewed from the side of the truck. The angle can range from positive to negative. Positive caster is the tilting of the top of the kingpin toward the rear of the truck. Negative or reverse caster is the tilting of the top of the kingpin toward the front of the truck. Positive caster imparts a trailing action to the front wheels, while negative caster causes a leading action. The correct amount of caster helps to keep the front wheels in the straight-ahead position. Positive caster acts as a lever, assisting the driver to return the front wheels to the straight-ahead center position. However, the truck will pull to the side with overly negative caster. Caster specifications are based on vehicle design load with no payload, which usually results in a level frame. Possible causes of incorrect caster are sagging springs, a bent or twisted axle, or unequally tightened spring U-bolts. Caster on the passenger side must have a higher degree angle than the driver's side, but the difference should not be more than 1 degree. This accommodates the crown of the road. In most cases, if caster varies more than the specified 1 degree between the left and right sides, it's caused by a twisted axle. If caster must be corrected, tapered shims can be used as needed between the springs and axle. Spring U-bolts should be tightened evenly and to the specified torque after the addition or removal of shims. To increase caster, insert the wedge so the thick end faces the rear of the truck. To decrease caster, place the wedge so that the thick end is toward the front of the truck. If an excessively thick wedge is required for a truck that has high mileage, check the contour of the springs and replace the springs if necessary. Refer to ICES for further details on how to measure and adjust for an incorrect caster setting. For more details about caster, refer to TSI 04-02-01 on ICES. Camber is the amount in degrees that the wheel tilts away from vertical at the top, as viewed from the front of the truck. It is determined by the kingpin angle built into the axle. Because the camber angle is set at the manufacturing plant, it is not recommended that the front axle be bent to change the camber angle. Positive camber is an outward tilt of the tires, while negative or reverse camber is an inward tilt. An incorrect camber angle causes the side of the tread to wear. If camber angle is found to be wrong, it is an indication of a bent or improperly installed axle. Unequal camber in the front wheels may cause the truck to pull to the side that has the most positive camber. To ensure that the front axle is properly installed, it is important to note that the name tag or the word front must go to the front of the truck. Mark the axle if necessary for reassembly. For more details about camber, refer to TSI 04-02-01 on ICES. This concludes Program 5 of the Power Steering Training Series. Completion of this educational process is a key component toward International Technician Certification. You are now required to take a post-test via ICES, Education, Service, online testing.